Now next we want to check these functions map, filter and reduce. And plus we want to see one concept of decorators. A decorator is a concept which is also related to function. So before going further, we want to see some options related to function. Okay, so we'll go for that first and then we'll come to this map reduce functions once again. So see, in Python we said that everything is an object. Okay, Python is fully object-oriented language and everything is defined in terms of object. Means data types what we have used in float, string, all these are just nothing but an objects. Okay, so on that line, functions are also considered as an object. Okay, functions in Python are just nothing but an object. So whenever you are writing some x function, okay, or suppose say y function, z function, these names that we define are simply identifiers bound to these objects. Okay, so see, understand this concept that functions are objects. Okay, if you understand this concept, then you will understand very easily what is mean by decorator or how we are using this map reduce functions and all that. Okay, so we'll see some examples how we can define function as an object. So once you understand that function as an object, you need to understand that we can send function as a parameter to function. Okay, function can be written as a return value from a function. Okay, we can provide different names to a function. Okay, so see some operations what we can carry out on a function. So here see, we're writing one function like same first. Okay, name of function is a first, and through this function we are just printing one string message. Okay, this function we can call like this by providing some string value and it will print that string on screen. Okay, that's straightforward. It's printing hello on screen here. Okay, so that's straightforward. Now see here, we can say something like this. That is one important aspect. We can say second is equal to first. What it means, various different names can be bound to the same function object. Okay, first is just nothing but an object as it is a function. So you can, means like second and first can refer to the same function object. Two names can refer to the same function object, and even you can call this function by using this name also. That is first idea to consider that function is just nothing but an object. Okay, these names what we are using in our program like say first, second are simply identifiers bound by these objects, bound to these objects. Okay, next. Now second option what we want to learn is that functions can be passed as arguments to another function. Okay, functions can be passed as an argument to another function. Like say, here see, we are having one function inc, and through this function we are just incrementing value of this parameter by 1. Then another function that is dec, through this function we are just decrementing value of x by 1. Now see, there is another function that is operate, and to this function we want to send either this inc function or dec function as an argument here. So here we are just writing one parameter, suppose say func func, and then we are writing one value. Then now we don't know which function is passed as an argument, either this inc or dec. So whatever function we are calling it, we're passing this x variable, and whatever return value we are storing in this r, and this r we are returning from here. Okay, now see how we can call this function. We can call this function saying operate. Now here we are calling this function by name inc, we are passing value 10. Same function we can call by passing this dec also. So what to understand in this code, what we have written, that we can send function as an argument to another function. Function we can send as an argument to another function. So in this case, this function, operate function, is a higher order function. Okay, this function which takes another function as an argument is known as a higher order function. So in our case, operate is an higher order function. Okay. So up till now, see what we have said regarding with function. First of all, in Python, everything is object. So on that line, function is also nothing but an object. So we can assign one function name to another variable. In that case, you imagine it like that, that function name is just nothing but an object that we are referring to another variable. Second thing, we can send functions as an argument to another function. In that case, a function which takes argument of another function is known as an higher order function. So in our case, operate is an higher order function. Next thing, now what we want to learn, that we can define function inside another function, that is known as an inner function. Okay, we can define one function inside other functions. Such a function is known as an inner function. So suppose this is our function known as an outer. So inside that we can write another function, suppose say name as a inner function. Okay, here we are just printing one statement, inner function. Okay, and then in outer function we are writing inside outer function, and through this outer function we are calling this inner function. See, when you are calling this outer function, you'll see output like this: inside outer function, inside inner function. So first of all, this function is inner function because we defined it inside this outer function here. So we can do it, we can write function inside another function. Next thing, inner function not defined until parent function is called, means until we call this outer function, this function will not be get defined. Then inner function is locally scoped, means we can't use this inner function outside this outer function. Okay, it exists inside this outer function just like a local variable. So that is possible. You can define function inside another function. That function is known as an inner function. That inner function only gets defined when you call outer function. You can't access that inner function outside that outer function. Inner function is locally scoped. It exists inside that outer function just like a local variable. Okay. Now last point what we want to learn regarding with function is that a function can return another function. Okay, a function can return another function. See how we can define it. Here we are writing, suppose say this function is a parent function, okay, and we are keeping this function as an inner function only. From this function we are returning this function. Okay, here we have created one function that is a parent. Inside that parent function we have written one inner function, and that inner function we are returning from parent function. Okay, so see how we can call this now. Here we are calling this parent function, and in return of this parent function you will get inner function. So currently we are storing it in one variable, or say we'll just give one different name like inner val. Okay, so when you call this parent function, that parent function returns this inner function that we stored in another variable, that inner underscore val, and through this variable now we can call that inner function like this. Okay, so these are the all operations we can carry out with function in Python. Just summarize it once again. Python function is just nothing but an object. You can pass function as an argument to another function. A function can return a function as a return value, and we can write, or say we can define one function inside another function. Such a functions are called as inner function. So just remember all these concepts because we are going to use it with our next topic like map, reduce function, and decorators and everywhere. Okay, now we'll see what is this map, reduce, and filter function. Now check this map, filter, and reduce function. So first of all these functions are inbuilt functions of Python, and all these functions are higher order functions. Okay, so right now we said higher order function is just nothing but a function which either take functions as arguments or return functions as a output. So all these three functions, map, filter, reduce, takes function as an argument. So that's why these are functions are known as an higher order function. So we'll see one by one. First we'll go for a map function. Okay, now see, map operation takes a mapping function and a vector of data. Vector just nothing but a collection, a sequence. We have seen list, string, set, dictionary, all these tuple, all these are can be considered as a vector. Okay, so map function takes two arguments. First one, that is a mapping function. Second one, that is a sequence, and it returns a new sequence which is the result of applying the mapping function on each element of the vector independently. See once again, map operation takes a mapping function and a vector of data as arguments and returns a new vector, which is the result of applying the mapping function on each element of the vector independently. Means like here you can see this is a signature of map function. It takes two arguments. First argument is a function argument. Second argument is a sequence. Vector of data is just a thing but a sequence. It's a collection. Okay, so we are passing two values to this map function. First one, that is a function. Second one, that is a list, sequence, or use whatever word. Okay, and this function applies on each element of this particular sequence and it returns new sequence from this particular map function. Okay, now returned value from a map is a map object. Okay, this map function returns a value which is just nothing but a map object, and that we can pass to functions like list or set, and we can create list or set from this map object here. Okay, so see how we can use it. First we'll create one operation without using a map function, so we'll understand exact use of map. So suppose there is one list which is a list of some radius values. Will you go with some different values here? Okay, see, consider this list R which contains different radius values here. Okay, then we are having one method area by which we can calculate area of a circle. So here we are just returning area of a circle. We'll just import pi value. From math we are importing this pi value, and from here you return area of a circle. Okay, so this is how we are working. One list is there. In fact, we'll just change the name of list here. Just say radius, so that warning will not be there. Radius is a list which contains some radius values. Area is a function which takes radius as an argument and returns area of a circle. Now if you want to call this area function for all these radius values, what we have to do, we need to write down a loop. Okay, we need to write down a loop like this, and then we can call this function with this radius value, and you will get whatever area. Okay, so this is how we can call. Here one function is there, radius, area. One list is there, radius. We are calling area function for every individual value of a list here. So that is the work of map function. That's what we have said here. Map operation takes mapping function and vector of data as arguments and returns a new vector. So same operation what we carried out here, we can manage by means of a map function. Okay, so now list remains same here. This area function remains same. Only see how we can use map function now. Here we are calling this map function. See parameters of this map function. First is just nothing but a name of a function. Second is iterable, means list. So first parameter or first argument is just nothing but name of function, that is area, and second one, that is a sequence, that in our case radius. So what happens when you call this map function? This map function calls area function for every value of this radius list, and in return, see, that is important thing, this map function in return gives you map object. This map function in return gives you map object which we can pass to list function, set function, tuple function, and we can create a sequence as per our requirement. So in our case we pass this return object to list function and we will get one list, suppose say T. Now we can print this list directly. So here you are having one list which contains areas of a circle according to this radius list. If you call tuple instead of list, you will get one tuple here. If you call set function over here, you will get one set over here. Okay, so map object we can pass to any sequence object like set, tuple, list, etc. So this is the operation of map function, which takes two arguments, mapping function and collection. It applies that mapping function to individual value of a collection, and in return it gives you map object. That map object we can pass to any sequence functions like list, set, tuple, and we can create a new sequence. by using map function. Okay, so see some variations over here. Suppose if your map function contains more than one parameters, then how we can work here. This is our map function now, which takes two arguments here, add, return a plus b. So this is our mapping function. In this case, we can call this map function like this, same map, first name of that function, mapping function, add, and now we are passing two lists here. Okay, first list and second list, as our function takes two arguments here. Okay, this is a mapping function. In return, you will get map object, which we can pass to list, and we can create a one list here, which is just a thing but addition of these two lists. Okay, so this is also possible that your mapping function can take more than one parameter. So in that case, you need to pass those many lists from to this map function. Okay, next, now see if your function is smaller. Just in our case, how you can see this add function is very small function. Instead of writing this function definition separately, you can go for anonymous function, that lambda function we have seen. Okay, and we can write down this function as a lambda function. So in our case, we can directly say here, see, instead of writing this add function like this, we can call this lambda keyword, then pass the arguments and return value you can write like this. Okay, so same result will be there. The only thing is that instead of writing that function definition explicitly, we write it by using this lambda anonymous functions here. Okay, in fact, in most of the time we are going with lambda because these mapping functions are smaller functions that we are using to create some square, cube, and some small kind of operations only. So mostly for map, filter, reduce, we are going with anonymous functions instead of explicit functions over there. Okay, so finally understand the work of map function. Map function takes two parameters, mapping function, vector of data, apply mapping function on each element of vector and returns new vector. In fact, it returns a map object. That map object we need to pass to functions like list and set to create a new vector. Okay, so this is regarding with map function. Now I'll check filter and reduce functions. Okay, now see filter function signature is also same like a map function. It also takes two parameters. First one, that is a filter function, and second one, vector of data. See, once again, don't confuse with the word vector of data. Vector of data is just nothing but sequence collection. Okay, so in previous case we have seen a mapping function. Now we are working with filtering function. The filter function operates on a list and returns a subset of that list after applying the filtering tool. Check here. Suppose say this is our list which contains numbers from 1 to 10. So this is our list. Now we want to create one new list which contains only even numbers from this list here. Okay, we want to create one new list which will contain only even numbers from this L list. So that is our filtering rule. Okay, that is our filtering rule. So that we can define by using one function, suppose say even. Okay, and from that function we are just returning here. We are applying this filtering rule here like this. If this number is even is a filtering rule, so we are just checking whether given number is even or not. If it is even, then we are returning it from function here. So this is our filtering rule, this is our collection. Now we want to apply this filtering rule on this collection using this filter function. So once again, check the parameters of filter function. First one is that is a filtering function, second one is an iterable object. So here call this function. First parameter is just nothing but this function name, and second parameter is this list. So in return you will get one filter object that we can store in some variable, suppose say f. Okay, and just pass this f variable to list, and that will create one list. Okay, so run this code and you will get one new list which is just nothing but which contains only even numbers from this list here. So this is a filter function. Okay, now here in this case also, instead of writing separate even function, we can go with lambda function. So here see, we are removing this even function call, and instead of that we are writing this lambda function. Okay, so it's very easy way to define this filter by using this lambda function instead of going with this even function. So just remove it from here. You will get the same result once again. So if your functions are smaller, means with only one single statement, it's better to go for lambda function instead of going with regular functions. Okay, so this is regarding with filter. Now next we'll see reduce function. Okay, now up till now, see regarding with reduce function, signature once again remains same. It takes two parameter. One is a reduce function and one is a list. But output of this reduce function is a single value. And so up till now we have seen in map and filter function we are getting new list by as a return value from these functions. But in case of reduce function, you are getting only single value as an output. So see, the reduce function will transform a given list into a single value by applying a given function continuously to all the elements. Reduce function will transform given list into a single value by applying given function continuously to all the elements. So it basically keeps operating on pair of elements until there are no more elements left. Okay, so you better will understand it by one example. Once again, we'll go with same function, same list rather, L, which contains values from 1 to 10. Now see, reduce function is this function. This is our reduce function. This takes two parameters now, x and y. What we are returning is just nothing but x plus y. So now see what we are doing. We are just creating pair of these values like 1 plus 2, 3 plus 4, 5 plus 6, 7 plus 8, 9 plus 10. Then we are once again applying plus operation on that return values, and this way we will just carry out until we will get one single value from that list here. So see how to apply this with using reduce. Now in fact, one thing we need to know that this reduce function is in one another module now. That's not a or in built-in modules here. We need to import that module here. So name of that module is functools. From functools import reduce. So import this reduce method, reduce function rather, and then call this reduce function. Pass this function as a first parameter and then list as a second parameter, and you will get summation of all these numbers because we are just carrying out sum of these two numbers here. See, understand how it is working. It is working on two numbers at a time here. So first it will create 1 plus 2, that is 3, 3 plus 4, that is 7. Then it will add those two numbers, means like 7 plus 3, 10. Then it will do the same operation for next two number pair, and it will carry out until it creates one single number here. So if you consider our reduce function, what we have written, finally it will just creating summation of all these numbers here. Okay, and no need to say, we can write down all these things by using lambda now. Instead of writing this reduce function explicitly, you can go with lambda function here. So say lambda now, this time don't forget we are having two parameters, x and y, and here we will say x plus y. So result will remain same. Okay, so these are three important functions, built-in functions: map, filter, and reduce, which operates on a collection and returns you either new collection or a single value in case of reduce function. Okay, map and filter we can use directly. For reduce, you need to import this module functools. Now see, we can use this function in combination also. Means like this map, filter, reduce function we can use in combination also. Okay, so first we'll check one example where we are using filter within map. Okay, means we want to call, it means there will be one list. We will first filter that list and then we will map. So see, idea is somewhat like this. Suppose this is our list which contains values from 1 to 10. Okay, now what we want to do, we want to create a new list which contains squares of even numbers only. Okay, so that is our aim. Create a new list of squares of even numbers from L. So even numbers means we will go for filter operation, and squares we will go for map operation. So first we will go with L list, filter it so that we will get only even numbers, and then we will create square of those even numbers by using mapping function. In our case, we will write down everything by using anonymous function, lambda function. So see, now we can write down it. So here first we are writing this filter function. To this filter function we want to write down filtering by using lambda. So the lambda function. What we want to check whether number is even. So just say lambda x modulus 2 is equal to 0. So it is even number. And what to pass to this filter? A collection which is L. Okay, so outcome of filter function will be a list which contains only even numbers. Now this outcome we want to pass as an input for map function. So here we are calling this map function. Okay, and what is mapping function? That once again we will write down by using this lambda function. So mapping function is just nothing but square of given numbers. See how we have written all these things. Check here. First we apply filter here. Outcome of this filter we are passing as a parameter to map function, and here we are applying this mapping. And whatever outcome of mapping that we are passing to one list here. In that list we are printing. So finally you will get one list which contains squares of all even numbers from L. Here you can see the square of 2, 4, 6, 8, 10. Okay, so this is the way you can use this functions in combination also. Now this combination we can do in another way also, that we can call map function inside filter function also. So see, comment out it here. Now in this case first we will call map function. Okay, function definitions will remain same. So here we will write down same thing. Okay, now list we are passing as a parameter to map function. Okay, so only we are changing sequence. Baki idea remains same. Here we apply this mapping function to list, and then outcome we are passing to filter function. And filtering rule once again remains same. Lambda x modulus 2 equal to 0. This is your collection. Okay, this whole output we are passing to this list function. Okay, so once again you will get the same list. So either we can implement outcome of filter you can pass to map, or outcome of map you can pass to filter. Finally what we want to understand is that we can use these functions in combination, and now no need to say we can pass all this output to even a reduce function, and we can use this third function also. So check now using reduce. Now for reduce we know we need to import this functools module. Import this reduce function. See here, we'll do one thing, we'll write down in the same statement only. Here we are calling this reduce function now. Okay, definition of reduce function will keep like before, passing two values, and this will return sum of these two values here. Okay, here understand it now. Using all these three functions in one single statement using anonymous function, obviously. See first from here, this is our first function, map function, which takes one list and apply mapping function, returns a new collection. That new collection we are passing to this filter function. Okay, so filter function apply filtering rules, it creates a new list. That new list we are passing to this reduce function. Reduce function reducing that list to a final one single value, which is just nothing but once again a summation. So this will be a sum of squares of all even numbers from this list here. So see, it's very easy to write by using map, reduce and map, reduce and filter functions. Means like if your program statement is like this is one list, and now find out summation of squares of even numbers of this list. We can write it down by using only one single statement like this, by using this map, reduce and filter function. So a very effective way to apply some rules, first apply some filtering rules, apply some mapping rules, or some reducing operations on a collection. These library functions are very helpful one: map, filter and reduce.